So I would like to introduce to you Michael Staab. Michael is a Cosmosphere Camp alum and previously worked at Jet Propulsion Laboratory out in California. He has recently taken a new position with Northrop Grumman. He's the Fault Management Systems Principal Engineer for the Lunar Lander and the Lunar Gateway missions. So, in his own words, he's flown a spacecraft around Saturn, guided a solar power rover on Mars, and contributed to the design of the next great Earth observatory. So, I like to joke with him, he's done some pretty cool things, in my opinion. If we could virtually welcome Michael Staab.
Well, thank you, and welcome to Launch Day. Very exciting. Missions like this is the culmination of sometimes a decade of work to get to a point where the vehicle is now has gone from a concept to we've manufactured the hardware, we've integrated everything together, we've tested it to the extent that we can test it, we've now put it on top of the rocket, and now it's time to go to Mars. Windows like this, opportunities like this only come around for about 4 weeks every 26 months. So it really is a race against time to get everything ready to go so that you're ready to launch. Doesn't help that this also happened in the middle of a global pandemic that shut a lot of things down. The NASA teams did an excellent job, as well as the United Launch Alliance teams, getting this vehicle ready to go to meet this launch window, because if we had missed it, we would have to sit on the ground for 26 months and wait for the next launch opportunity that would be around September, October of 2022. So it's a great thing that we made it to this point. The NASA Perseverance mission is the first true dedicated biological detection mission that NASA has ever funded. So the idea here is that we are sending a rover with a suite of instruments that have the capability to assess the biohabitability of a location on Mars. In this case, we're going to a place called Jezero Crater. It's going to assess the biohabitability of that location to determine if it had all the necessary ingredients to support life there in its ancient past. We're not saying that it may be life right now, but maybe ancient life. And what it has is a suite of instruments to assess that habitability and a core sampling instrument called the sample caching system that is going to take up to 40 core samples of this region of Jezero Crater. It's going to store them on board, and it's going to leave those samples on the surface for eventual retrieval by a mission concept currently in development by NASA and the European Space Agency called the Mars Sample Return Mission that would land on the surface, that would land on Mars, would send a rover out to fetch those samples, return it to a lander, put it inside of a rocket, launch it into Mars orbit, and then have a spacecraft come by and grab it, leave Martian orbit for a return trip to Earth, and deliver those samples back into the Utah Salt Flats sometime in 2031. So it really is a decades-long mission to make this happen. To give you an idea of what's happening today, this is what we call the LEOPS mission phase. This is the launch and early operations mission phase. It is one of the most dynamic mission phases of any spacecraft mission. For Perseverance, this will be a walk in the park compared to what we will be doing in February, which is entry, descent, and landing. So as the name implies, LEOPS stands for launch, early ops. So the big thing we have to do today is launch the spacecraft. We have to get it out of Earth orbit onto a particular place at a specific time at a certain speed. Because if we don't do that correctly, we don't intercept Mars in February. So the rocket provides the primary thrust and the primary delta V, the velocity change required to make that intercept with Mars. It's flying today on an Atlas 541. That's United Launch Alliance heritage vehicle. Atlas 5 uses a Common Core booster with 4 solid rocket motors, a Centaur upper stage, and a 5-meter payload ferry. What we'll see today, we're going to get off the ground. After the first Centaur burn, we're going to go into about a 30-minute coast phase, go into eclipse around the planet, and then after that 30-minute coast phase, we're going to light the engine back up again, and that's going to provide the necessary energy to get out of Earth orbit onto a Mars interplanetary trajectory. For today, I was just checking some of the weather numbers. We're currently holding at 80% of go, which means that there's only 20% violation that we will not make the window today because of weather. The range is currently green, and there are no other conditions I've heard with either the spacecraft or the launch vehicle, so everyone is currently on track today. For the launch window itself, it's a 2-hour window, opens at 7:50 a.m. here on the East Coast, lasts for 2 hours, and there are 5-minute launch opportunities throughout that window, which means we have 24 attempts to get the rocket off today. If we don't fly today, we can go again tomorrow, as well as every other day up until August 15th. Beyond August 15th, Earth and Mars are too far away from each other that the rocket doesn't have enough energy to get to Mars. So we would have to stand down on the launch, and we would have to wait 26 months for the next opportunity. Not saying that's going to happen. We also know that there is a hurricane kind of turning off to the east of Florida, so it's not going to impact today, but we definitely know that we're running out of time. So everything looks good for today. It looks like we're going to get off the ground. A couple more pieces of information. This will be the 9th landing attempt by the United States to land something safely on the surface of Mars. We haven't always been successful, but in recent memory, from the Pathfinder mission, the two NER rovers, Spirit and Opportunity, Phoenix, Curiosity, and Insight in 2018, we have had a successful track record so far. So fingers crossed, we will get to that point. First, we got to get off the ground. So what I'm going to do now is I'm going to switch to the NASA live feed so we can start watching the programming as it happens live. So just 1 second.
So usually we're able to be here working beside them on their equipment and making sure that all of their needs are covered even before they ask for it. It is a challenge, but we're used to meeting unique requirements here at the hangar, and we pride ourselves in our flexibility.
This is just another mission, just with a different set of obstacles that we have to overcome. It might not be, like a broken rocket, but it's it's got its own challenges.
Our job is to go into the unknown. And this is just another example of the unknown. How to make this job happen when you're doing it largely through a computer screen.
I asked the team a couple months ago if they would like to do something to kind of symbolize and mark these challenges that we faced, and they designed something that we called a COVID-19 perseverance plate that's now affixed to the port side of the rover. It has a globe representing all of us that face this challenge together, the spacecraft leaving the Earth on its way to Mars, and all of this supported by the now familiar staff and servant of the medical community. And we hope that this mission, in some small way, can inspire them in return. Pretty much everybody that I've talked to that's associated with the mission has said the same thing. You could not have come up with a better name than Perseverance.
We have persevered through this. Nobody's given up. We won't get this mission done. We will get it done through the pandemic.
I think it's a really important symbol of humanity, hopefully persevering through this great challenging time that we have right now.
We appreciate that team as well as the medical community that really stepped up and helped. And it's ironic, Moo, because the name Perseverance was chosen by a 7th grader who at the time he submitted that name, he didn't know that we would be faced with a global pandemic. So we are glad to have him and his family here, along with the student who named the helicopter, to watch the launch in person.
Their names are Alexander Mather and Vanessa Rupani, and they are watching from the 5th floor balcony of our engineering building, just a stone's throw away from the countdown clock. Look at that, there they are, looking cool. Alexander Mather, who goes to Lake Braddock Secondary School in Burke, Virginia, submitted the winning essay to name our rover Perseverance.
Yeah, they've got a great view from up there. They've got the VAB in the background, as you can see there, so cool. It's such a beautiful setup for this awesome launch. And Vanessa, who you can see her, waving. Hey guys, appreciate you. She's a junior at Tuscaloosa County High School in Northport, Alabama. She entered the contest as well and came up with the name Ingenuity for our helicopter that will accompany our rover to Mars. Thank you both for being here. What a neat view that is.
Yes.
All right, folks, with the coast phase coming up, we want to let you know that after the launch, it will be about an hour before Mars Perseverance separates from the second stage. When that happens, the rover will then be on its way to Mars. So hang in there.
Yeah, don't go away, as we will walk you through the flight around the Earth, and we'll talk live with the astronaut Zena Cardman about our human exploration ambitions and NASA's Associate Administrator of Science, Dr. Thomas Zurbuchen.
It's going to be great, folks, so stick around. It's L-minus 6 minutes and 26 seconds now, and time to focus our attention on the launch operation the rest of the way to liftoff. So let's send it back out to Mick Woltman and Joshua Santora. Gentlemen.
Thank you. I want to let you listen into the remainder of this poll in motion. Let's go to that now.
Range coordinator. Clear to proceed. Launch director.
LD is go, and you have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 1150 Zulu.
So 1150 Zulu. That is 7.
Watching Josh do the calculations.
So basically what they did is they went through the final poll.
So there's a lot to come ahead. One of the things coming up in just a few seconds.
5 minutes, 30 seconds.
OS, NSC. Go, NSC.
Spacecraft on internal power and timer set for T0 of 1150 Zulu.
Roger. OS, start list data capture.
Roger.
Basically, the
Fantastic.
launch
Steps are complete prior to terminal count. LC switch
the
is
launch
ready.
vehicle is clear. The spacecraft is clear.
Awesome. So things are really starting to pick up here. You're going to hear
Yes.
more and more chatter on those nets there. That call was to say that Perseverance is powered and ready to go, which is a phenomenal call.
Yeah, a couple things happened during that time, right? Is launch conductor, ULA's launch conductor, Scott Barney, pulled the whole ULA team. They were all go. We got to
The
hear
third of our 5 teams.
The third of our 5 teams. We got to hear the end of that where the range was clear to proceed, and ULA's launch director, Bill Cullen, gave the authority to go for launch this morning at 7:50 a.m. Then we got to hear from the JPL spacecraft team that they are
the fourth team,
that they are on internal power, and timers are set. They are targeting a liftoff of 7:50 a.m. this morning. So all things are looking good for us, Joshua, this morning. It's so, we talk about being nervous and excited. This is right here where we're nervous and excited.
Yes.
There are a lot of things happening as we get ready to count down to the liftoff this morning. We have about 15 seconds left in this hold before we pick up the count.
Yeah, we're going to listen into that. The fifth team, the one we haven't mentioned yet, is the Department of Energy, who is responsible for the MMRTG, the power source for Perseverance.
3, 2, 1, mark.
Awesome. So this is now the terminal countdown. This is that time when things become more and more automated over the next few minutes, and the energy's building, but the focus is increasing exponentially.
Yeah, as Tori said during his interview, the teams are very disciplined, very focused on what they're doing, the operational sequence of events that they're following. They are making sure everything happens, especially in this T-4 and counting period, because there's a lot of things they have to do. They have to finish topping the vehicle, make sure that all the tanks, first stage, second stage on Centaur, are at flight pressures and full of fuel, ready to go for this morning. They have to make sure the FTS system is armed and ready for personnel safety just in case, so that the range can do that. They have to check the electrical and avionics systems. They have to make sure that the flight computer has all the information it needs to place Mars 2020 into the orbit it has to. So a lot of things going on. Exciting time for the team right now, but again, staying focused and following that procedure they've got.
3 minutes.
As we look ahead to post-liftoff, want to kind of preview for you what's going to happen, because there's going to be a lot going on. You're not going to hear much from us. You'll actually be hearing from the ULA flight commentator, Jesse Gonzalez. He'll be kind of giving those calls past liftoff that will walk us through maximum dynamic pressure and into SRB separation, and then into fairing separation, booster separation, and then the first main engine ignition of the Centaur,
yes.
RL-10. And so then you'll kind of hear us jump back in and help provide some more context to what's going on. We encourage you to stay with us for the rest of the show. That there's a ton more content we have to bring you, and we are far from over. Want to emphasize that the countdown to Mars is not done at 0 today. The countdown to Mars ends in February, when Mars 2020 safely delivers Perseverance and Ingenuity to the surface of the red planet. So we're going to let you listen in now and enjoy the last couple of minutes of the process of launching a rocket.
1 minute 59.
Okay, so
Vehicle internal.
1 minute 55.
there's going to be quite a
Launch
bit of
sequence to
fallout.
start.
1 minute 50.
Securing Centaur Leech 2.
Securing Centaur LO2.
Okay, so that means that they're topping off the rest.
So there we heard the
of
fueling is
1
wrapping
minute
up there.
40.
liquid oxygen.
Yeah,
on
fueling
the
is wrapping up.
Centaur
The
stage,
team is
and then
done.
the
Launch enable's
137.
done. Launch conductor sequence is ready to go. They're getting ready to turn the vehicle over to auto
FPS
sequence at T minus 31 seconds. So that's a big thing that they're getting done here. At T minus 25 seconds, we will hear the team give their final goes that everything is ready and
1
the
minute
launch
20.
vehicle is ready to lift off and
OCU
perform
armed.
this mission.
SCS count
1
started.
minute 15.
Produce CCS for launch. Roger.
1 minute 10.
Then valves locked.
One minute.
Rock, report range status.
Range green.
That's good to hear, Joshua, right
That means
there.
public safety there is accounted for. The FTS system, there you see on your screen a beautiful shot. The skies look great. There's little wind happening. You'd be able to see more of the venting. If there were wind, the trail of that venting. So we're ready to go.
And actually, that's an
40
important point.
seconds.
The reason we don't see that
Stable at
venting is the
F3.
vent valves have been locked up to put flight pressure into the tanks. And as we just heard, they're stable at step 3, which means the tanks are ready to go. And here at about 5 seconds, we will
28
hear
seconds.
the team
ECS reduced for launch.
give their
Roger.
final go.
25 seconds.
Status check. Go Atlas. Go Centaur. Go Mars 2020.
There we go. We are ready to go lift off this morning, Joshua.
That's the water suppression system that's firing.
8, 7, 6, 5,
Five.
4. Engine ignition. 2, 1, 0. And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And Atlas TU has gone to closed loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1 Atlas 5 is now supersonic.
That's supersonic. There's a shock waves off the bow of the bearing there.
And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly. And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly. And we have a good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance.
The reason we get rid of those SRBs is after they have
Vehicle body
consumed
rates
all
are
the fuel,
responding nominally
they're
at this
just dead
time.
weight at this point. So they get them off the rocket so they can boost the performance.
And coming up on 2.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour. And the Centaur reaction control system is now pressurizing to flight levels. just past 3 minutes into flight. The RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good.
There goes the payload fairing.
And we have good indication of payload fairing jettison and Centaur forward load reactor deck jettison.
So that's a really important part of the mission, because that's the first time that the spacecraft is exposed to the space environment. We've simulated before, but
and the RD-180 is throttling back up to attain a 4.6 G acceleration. Engine response continues to look good.
So this booster engine burn will cut off here right around usually about 4 minutes.
And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation. Standing by for BECO shortly.
BECO's the call for booster engine.
And we have BECO, booster engine cutoff, standing by for stage separation. And we have good indication of Atlas Centaur separation.
That gas there, that's pre-start on the RL-10. That's normal.
So there you're seeing live footage.
And we have the Mach 1. RL-10 operating parameters look good. Chamber pressures are stable. This will be the first of 2 burns for today's mission. This first burn will be approximately 7 minutes in length.
So Mick, that's pretty exceptional footage there. That's live video. We will see that switch over shortly into an animation that kind of helps let us know what's happening with the rocket. But right there, a beautiful liftoff. Fun to feel that rumble in the building here as we proceed towards orbit and then towards Mars destination.
Yeah, absolutely. It was great watching an on-time liftoff of the Atlas V with that little over 2 million pounds of thrust. Cleared the tower in roughly 5 seconds. Josh, you and I worked the InSight mission, and if you recall, that mission on the West Coast took about 17 seconds to get past tower. So with those 4 solids today, this thing really got out of here and on its way. It's, as we hear from Jesse, everything's looking nominal, and all vehicle parameters are within the design limits, and we're getting ready to come up on a main engine start for that first burn that Jesse was talking about.
Yeah, so recapping this countdown to Mars, the stations began to be filled up this morning just after midnight. Preparations, fuelings, powering up, all the way through that liftoff that happened. I think, Mick, it wasn't precisely on time. I think you said it was like 10 milliseconds early. So it's pretty much dead on.
Yeah, dead on. This team does a great job. As I said, they're very focused, very disciplined. As Tori also said, courageous. They have done a lot of work to get us to this point today through this pandemic, changed how they did some of their work, made adjustments as needed, a lot of cleaning, a lot of things, a lot of wearing their face masks, doing all kinds of things. And so this is an exciting time, not only for the JPL team in Mars 2020, but everybody that's worked this mission, and for the country and the agency. So this is exciting to see. We still have a long way to go, Joshua.
Yes.
Before spacecraft separation.
Yeah, we had a really quiet countdown today, which is phenomenal, that we got off the ground on time. And we are proceeding now that we are in the middle of the first burn. It's tough to make out, but that engine is lit and it's firing. So we are in motion. There you go. There's that animation we talked about.
The telemetry there as we switch to a TDRS compatible data format.
TDRS
overall telemetry quality is very good.
The space tracking system. So there you go. This is not an actual video, but this is an animation that's driven by real data. So although we're not actually seeing the engine on screen right now, we can see that the engine is lit, and that is driven by the data that says that the engine is truly lit and we're in this burn.
Yeah, the launch vehicle continues to send telemetry to the launch team via the TDRS network, as you mentioned, and that allows them to continue to watch what's going on and make sure all their sequence of events meet their timeline. We continue on a nominal flight this morning. This first burn, as we heard earlier, will be about 6 minutes. This will get us into that park orbit around Earth, allow us to get on our way, and then get into that approximately 30-minute coast period that we're going to have.
8 minutes into flight, beginning to see the Centaur PU system balance out mass errors. seeing very stable body rates in the Centaur.
So we've mentioned 5 teams at play, and although if you were watching, hopefully you got a chance to see this in person, if not on camera, it's easy to kind of say, oh, it's over, like job done, but all 5 of these teams still very much engaged, still very much focused, because there's a lot of work ahead as we proceed through this first burn, and then a coast phase, like you mentioned, Mick, and then a second burn, and then spacecraft separation and the acquisition of signal from Mars 2020. So a lot more coming up here. Mick, I know for Launch Services Program, you guys manage the launch. So what does that mean? I mean, this is you guys' work in action right now.
By the way, that's the 5th team that we didn't get to mention. We talked about JPL, we talked about DOE, we talked about United States Space Force, and United Launch Alliance. LSP, we are like the brokers to select this launch vehicle and help with manage this mission. So we get our spacecraft customer, the JPL folks, they come to us.
So the one thing I want to point out
certain
here
requirements that they need for this
us
mission.
rocket scientists
The
care
launch
about
services
is
program made
for
up
this
of
first burn, we're
engineers
looking
and
at
flight
this
analysis
perigee
folks,
altitude in
and
kilometers. You
they
see, right
look at
now it's currently
everything, they help
negative. That means
define
that the
those
vehicle isn't in
requirements, and then we
orbit.
go out and
So if we were to shut the engine off now,
In this
after
case,
some
it was
period
the
of time, it
Atlas
would coast and it
541
would
for
re-enter
Mars
the atmosphere.
20 mission that was needed
someplace on
for
the other side of the
performance,
world.
right?
What we want to see in this
as
first
you and I
burn
have
is we
talked
want to see
over
that
the last
number
several days, Josh, one of the things that
go
was
from
important
negative
for us to look
to
at
positive.
was
That
that
means we're now in a
performance to be
capsule
able to
orbit. And
get
remember, this is just
Mars
it's just
2020
a
onto that
coasting
transfer
orbit. So
orbit
this
into
gets
solar
us
orbit to intercept
lined
Mars
up
in
for that second burn, which is going
7
to put us
months.
on
It's
that
kind of
interplanetary
analogous to a
trajectory
football
to
game,
get us
right?
out to Mars.
With
You
a
see here now they
quarterback
switched
trying
over to the
to
left
throw a
side of the
pass
screen.
downfield.
That
You need a
is
quarterback with a lot of
JPL's
performance
critical events
who
room.
can get that ball
That's
down there where it needs to be.
any major critical event like launch,
So the
landing,
receiver
or
can
insertion
intercept
takes
that.
place.
In our case,
the
7
room
months
is
later.
There you go.
particularly a
Yeah,
little
it's
barren
the
right now.
longest
It's
football pass
kind
ever.
of,
The Earth
kind of
is
not
the quarterback.
surprising because of
The
what's going on right
Atlas
now.
is the quarterback's arm.
Kind of the neat
Perseverance
thing
is the
here,
football, and
this
Mars is
gentleman
the
right
receiver.
here, this is Bob Weineweaver.
And
He was
what we
one of
also
my
talked about is that
former
technically,
ACE colleagues.
you could
he
launch
is
to Mars at any
he's the
time if you
lead
had a
flight
rocket that was
controller for the
powerful
mission,
enough.
So he's the
But
only
this is the
individual
launch period
other than
every
himself
26
and
months
two
or so,
other
as we talked
individuals
about,
in
that
the
makes
world who are
the
allowed
most
to send
sense
commands
because
to that
you
spacecraft
require the least amount of
as it
energy
makes
to get
its
to
trip
Mars because it takes a lot
from
to get
Earth
there. Obviously, like
to
the
Mars.
Atlas
So
541
whatever commands
is
have
a
to go up,
workhorse.
that is
Yes,
particularly managed by the individual.
I
Here,
love
the
that
flight
name for
director
the
as well
Atlas
as the flight controllers
541. But
on
we heard
these next
Jim
two rows back
Bridenstine, our
here.
NASA administrator,
The
tell
row
us
back
that
here in the
if
back,
we didn't
those
make this
are
launch period, we would be
VIPs.
down
Those
for
are
roughly
JPL
26
leadership,
months,
NASA
right?
leadership
So the period started July 17th and
So,
went and goes to
if we go
August
back
15th.
to
Today,
the
July
animation, we'll see
30th,
that
was
we are
one of those
almost
launch
in orbit, so
opportunities
we're
that we
getting
had.
very
We had a
close.
2-hour window, and within that window, we had several opportunities. To go
25
today.
actually,
Yeah.
25 opportunities.
And we launched at the beginning of the window on our first opportunity to get Mars 2020 going on its way. And that, that sounds like a lot, and it is. The flight analysis group, both at JPL, LSP, and ULA, did a lot of work to pick out those target sets and figure out where we needed to be. So they've done a great job, and we'll see how this mission continues.
So, Mick, tell us about the 2 burns required here, and we're actually coming up on the end of the first one. Ultimately, a lot of people probably, and myself included at some point, just like, why wouldn't you just keep firing the engines? Just fire all the way through and get to Mars in one shot.
So the first burn gets us into that park orbit we talked about. We've lifted off, we've left Earth, we've got into a park orbit around Earth right now. And while we're in that park orbit, we will perform some maneuvers to kind of roll Mars Perseverance and the Centaur and coast during that time, basically setting itself up looking at the sun and away from the sun to control the thermal environments that are on Mars 2020 during this coast period. That coast period will allow us to coast around into the position that we need so that we can have that second firing to get the velocity needed to head off into Mars.
Yes, and we will be back for that second burn in just under 30 minutes now. But for now, there's more to learn about this mission and all the amazing science that's involved. Daryl, back to you.
All right. Thank you very much. Great launch and great job, guys. Back outside now. To recap, an Atlas V rocket carrying Mars Perseverance rover launched on time from the Cape Canaveral Air Force Station at 7:50 a.m. Eastern Daylight Time.
Incredible.
Okay, Carla, do we have any questions right now?
And was then boosted into orbit by the Centaur's second stage. Perseverance is now preparing for a second burn that will put it on a trajectory toward Mars. That's just incredible to say. It gives me goosebumps.
It really is. And
we had Opportunity that actually just was shut off last year. We had Insight And now we've got our new rover, Perseverance. So why is there so much emphasis on Mars?
So the emphasis on Mars kind of dates back to the 1970s. During the Viking mission. So in 1976, NASA launched and landed 2 Viking missions on the surface of Mars to, kind of prove landing technology, but also to kind of answer a question of, did Mars once have life on its surface? And while Viking did have instruments that you could maybe make a claim that could detect life on Mars, the thing is just that the technology wasn't really there yet. Our understanding of the red planet wasn't there yet. It basically tried to answer the biggest question first when we had so little information about Mars itself. So after the Viking missions, we kind of reconfigured the Mars program to sort of start from the beginning and go back and look at the questions about, well, what does it take to have life on Mars? Or what does it take to support life? Well, you have to look back at what are the ingredients to support life. You need water. Water is a great solvent for building very long carbon chains. So you need water. You need organic chemistry. Those 4 elements that create those long carbon chains, those amino acids, your carbons, your oxygens, your chlorines, and I'm forgetting the last one here. But those 4 basic elements and those reactions that build those longer chains, you need an energy source, something that gets the spark, that gets those reactions to start churning. And then, of course, you need time. You need lots of time for those reactions to take place to build those longer chains. So we kind of took a step back and we had to reevaluate, does Mars have all the ingredients necessary to support, the ability to have life? So when we started with Mars Pathfinder in 97 with that landing, we had to prove, first that we could actually do mobile geology on the surface. So Pathfinder was the lander, and Sojourner was a technology demonstrator. And kind of the reason for that was, in order to really assess the habitability of an environment, you can't just stay at one place. You have to kind of go to other locations. So Sojourner was a technology demonstrator to sort of verify that capability. And of course, Sojourner was very successful in that. And out of that, we got the mobile geologist spirit and opportunity. Their mission was to determine if Mars once had water on its surface. The water's not there anymore, but the geological evidence that the water was there is still present. You can see it in the formation of the minerals on the surface. You can see it in the scouring on the surface of the rocks. There are clear signs in rocks that Mars once was a very wet place and had lots of water, and that sort of informs about its past climate. The pressure of the atmosphere was much higher, the temperature was much more temperate, and that's how you're able to have water in a liquid phase on the surface. So after we determined that Mars has water on the surface, now we have to answer the next question. Did it have the right climate? Did it have the right chemistry? So that's what Curiosity's mission was. Its mission was to assess the biohabitability of Mars. It's basically determine, did it have the right climate? Did it have the right chemistry? Did it have the right chemical makeup in the rocks to suggest that it had the right ingredients to make sure that make building those long carbon chains possible? And Curiosity, just like Spirit and Opportunity, very successful in its mission now, going on 8 years in August. Verified the same thing. Mars had a much more temperate climate in its past, and it had all the right chemistry to support life, basically to support the churning of life, building those longer carbon chains eventually to get to a point you may could have had single-celled bacteria. But the last major question that we had to ask ourselves is, well, was there life once they're on the surface? We have all the ingredients necessary. We've proven that we have the water, we have the chemistry. Now we have to go find the evidence of life itself, and that's what Perseverance is meant to do. It's meant to assess the biohabitability. It's meant to assess the capability of Jezero Crater to once support ancient life. The reason that we like Jezero Crater is that it was once an ancient river delta. So we believe that in its past, this crater had rivers upstream that flowed water and minerals and all sorts of stuff down the river and deposited itself in a river delta, which if you're looking for life, that's a great place to look. You just have to look at the Nile Delta to know that it's a very fertile place. It's a place with a lot of life going on. So what Perseverance is primary mission is to assess biohabitability of this region, to take core samples of those regions, to leave those on the surface for eventual pickup. I'm going to bring those samples back to Earth to try and assess, to look for evidence of fossilized life contained in those samples. Now, if we find life, that's great. And if we don't, that's also great. Science is great about the idea that, you know, just because you don't find the answer you're looking for doesn't mean that something's wrong. It just means that you may need to reassess your hypotheses and reassess the questions you're asking and reformulate what you're doing. But it doesn't necessarily mean that we did anything wrong. So that's kind of the buildup we've been going to over the last 3 years, is to get to the point of Perseverance, is to take the first core samples so that we can actually determine if this place on Mars, Jezero Crater, could once it's supported life, and then to get those samples back to Earth so that we can determine if that was the case.
Great. And I think
it's a long-winded question, but
no, I think you actually kind of answered in that the next question that we had, which was, what would life look like if we found it on Mars? If you wanted to expand on that, Michael.
It's not going to be anything complex. We're not going to find Martians. We're not going to find aliens or whatever. We're going to find very likely single cell bacteria, because we believe the scientists, what we call the field of astrobiology, which is a theoretical study between biology and chemistry and planetary science, to try and understand how life would form in other places outside of Earth. Just based on Mars's atmosphere and what we believe the kind of chemical reactions that were taking place, we don't think we're going to find anything super complex. At most, we believe we may find fossilized bacteria, but to find even fossilized bacteria on another planet, that's a source that says, another place in the solar system is able to support its own sort of, whatever you want to call it, its own genesis or whatever of life. It's able to form life in its own environment outside of Earth. So what does that tell us? It could tell us that life can form kind of anywhere, as long as you have the right ingredients, you have water, and you have the right amount of time. Life can form anywhere. And if we don't find this bacteria, well, maybe Jezero Crater didn't have it, but if we don't find it and we go to Europa and Enceladus, which are two icy moons out in the outer solar system, and we don't find life there either at places where we think they could be, then maybe that tells us that life is very special. It requires you have to be in the right place at the right time with the right ingredients, and everything has to be perfect or it just doesn't work. But to answer the question, we think, if anything, it's going to be single cell bacteria.
Okay, very good. And you've explained a little bit of this as well, but we know that Perseverance's mission is to collect core samples, but it's in a quite a different manner than any other rover that's collected samples from the red planet before. Can you explain a little more on that, Michael?
So what we have on board is an instrument called the sample caching system. It's actually 3 robots in one. It's a very complicated instrument. And the idea is, once we take our suite of instruments and we sort of assess the biohabitability of this environment or this area that we're looking at, we can decide the mission team can decide if they want to take a core sample. So what that entails is, on the end of the arm, there is a drill bit called a core bit. And what it does is it drills into the rock and it captures that material inside of the bit. The arm then transfers that into the collection area, which is kind of this rotating robotic apparatus on the front of the vehicle. It deposits the bit into that sort of rotating mechanism, and it'd be easier if I had an animation, but I'll make do with what I got. It transfers that bit inside of the vehicle to a core sampling tube, and what it does is it takes that sample, it seals it inside the tube, it does sort of a reverse planetary protection kind of analysis. So what it does is basically, if we take core samples of Mars, we bring those back to Earth, we have to prevent any potential Martian bacteria from getting into Earth's biosphere, because we certainly wouldn't want to introduce something like that into the Earth's biosphere. So we have to do reverse planetary protection. We have to ensure that nothing from Mars can get back to Earth. So it seals it, it cleans it, it sterilizes it, and then it puts it inside of a holding mechanism where we keep the other 40 or so sample caching tubes, and it's going to leave them there until at such point the mission team commands the vehicle to release and deposit those samples on the surface, and they're just going to be left there. Like I said earlier, for eventual pickup by the Mars sample return mission.
All right, very cool. This one is again about the Mars rovers. Are they all generally located in the same region of Mars, or have we been sending these different rovers to different regions?
So the rovers generally go to different locations on Mars. I don't believe there is any location we have sent a rover to twice, mostly because we kind of take the opinion that, well, we've already explored that place. We kind of already know what's going on there. There's reasons in the scientific community why they choose to go different places. Jezero Crater originally was a target for Curiosity, but because of the landing system and Jezero Crater is a little more tricky to land in, the team did not have the confidence that they could safely land in Jezero Crater. So they diverted it to Gale Crater, which is another location. It's not a river delta, but another location where we believed that there was good indicators of past habitability, past biohabitability that you could assess. So that's why it went there. Spirit and Opportunity were sent to two locations that we believed had the best chance of looking for hematite. And hematite is a mineral that can only form in a low pH water, so kind of an acidic water. It's an iron-based mineral that can only form in flowing water that's mostly acidic. So we used orbital images to try and figure out if that was the case. And Opportunity got very lucky and landed in a crater that had hematite all over the place. Spirit unfortunately didn't have as good a luck. She kind of had to work for everything that she got, but the Spirit rover eventually found evidence of past hydrothermal these hot lakes, these hot rivers. I'm forgetting the name right now. Basically, these places, hot springs. That's it. They found evidence of an ancient hot spring in I'm forgetting the name right now, but anyway, went to a crater itself, found evidence of past hot springs, which is a good indication of a place where you have this hot water and this sort of soup that's sort of mixing. It's a great place for those reactions take place, because you got this soup of all these different elements, and you got an energy source to let those reactions take place. So we send the rovers to different places to meet what the mission requirement is. So the mission requirement for Spirit and Opportunity was to look for water. The mission requirement of Curiosity was to look for signs of past habitability. Now Perseverance is going to Jezero Crater because we believe it is a great location to look for past life, and we have some better technology this time to actually land in Jezero Crater. So it's kind of a combination of the science requirements as well as the capabilities of the landing system.
Very cool. We all got to see Opportunity take a selfie when it was on Mars. Will this new rover be able to take video and or photos, and can it take a selfie?
Yes. Yeah, so there's a camera on the end of the arm, and they can do the same thing like Curiosity can do. They can take a selfie of themselves. This mission in particular has a lot of cameras on it. I think one of the neatest aspects of this mission is for the EDL sequence, we have cameras all over the vehicle, so we can watch. We can have a recording of the parachute deploying, the supersonic parachute that's going to deploy. We can have we're going to have video of the sky crane, the backpack as it releases away. We can watch that. We'll have cameras looking up towards the back shell from the top of the rocket backpack. We'll have cameras looking down on the rocket backpack to the rover. We'll have cameras looking up from the rover. So we'll actually be able to look and view the EDL sequence as it's occurring. Not necessarily from an engineering standpoint, you need to see that, but it's kind of nice to have video evidence to kind of show how it performs. So we're gonna have lots of cameras. We're gonna have some really great views of EDL in February. And on the vehicle, the rover itself, it's got navigational cameras. It has eyes, so we can see where it's going. It has spectrometers, which are cameras that can sense different chemicals. It's got cameras on the end of the arms, back towards the rover, so that it can take up close microscopic images of whatever area that it's currently studying. It's got cameras on the front of the vehicle, on the back of the vehicle. We call those HAZ cameras or hazardous cameras, so the vehicle can avoid driving over something that it really shouldn't be because it could damage.
Wow, so it's got a whole lot of capability then, but there is a delay in receiving that. Is that correct, Michael?
There's always a delay. The minimum, typically how the operations work is we work on something called Mars time. I have never had the pleasure of working on Mars time, and I hope I never have to work on Mars time because Mars's day is roughly 40 minutes longer than Earth. To stay on a consistent Mars time to do operations at the same time every day, the team has to come in 40 minutes later every single day, all the time. It's not very fun. But typically how we operate the vehicle is we get a downlink, so we get data from the vehicle telling us how it did, how the last plan went, various things like that. We take that data, we use it to build the next day's plan, whatever that is. Then we send that up to the vehicle will execute that plan, and then it'll check back in sometime later with data once it talks to some of the orbiters that relay its data back. So there is a delay. If we do anything real time, at minimum, I think the minimum one-way light time is something on the order of 3.5 to 4 minutes. That's the closest that it can get. At the farthest, it can be as much as 30 to 40 minutes.
Okay, so sometimes we get a little more faster response here. So going back to the launch, we had a question about those pieces that were jettisoned away. Are those pieces recovered or do they burn in the atmosphere?
So the boosters, so the solid rocket motors, the booster, the payload fairing, all that stuff just goes into the ocean. There's no plan to recover it. SpaceX is a little different in how they do things. They're much more aggressive in trying to recover things. But have to remember that when Atlas was first launched, that kind of technology was still very, very science fiction. It's very difficult to do. And at that point, there was no real economic advantage to recovering your booster, at least to try and design that capability. So those pieces, once they are used, they are jettisoned from the vehicle. You no longer need them, and they just fall into the ocean, and they sit.
Okay, very good. We were chatting here before we went live this morning, and you mentioned that you did not get much sleep last night. Can you tell us what about these types of launches makes you nervous, Michael, as a person from the inside?
Well, for having contributed a small piece to this mission, you're always kind of nervous when you wake up on launch day. Just because everything this team's been working on for almost 10 years comes down to about an hour-long sequence of lighting the rocket, getting into orbit, and then getting on the right trajectory. And to get to an interplanetary destination, you need three things. You got to be in the right place at the right time at the right velocity, because we're trying to intercept Mars. We're aiming the spacecraft where Mars is going to be 6.5 months from now. So there's a very specific location in inertial space that we have to hit in order to get us on the right trajectory. we also have to be at the right place. So that's the place. We have to be there at the right time, because the timing is very important. When you're leaving Earth's orbit, you got to be in the right place at the right time. And then you got to be going at the right velocity, because if we're going too fast, we're going to overshoot Mars. If we're going too slow, we're going to undershoot Mars. We're not going to make it. So the precision of the launch has to be, the accuracy of the launch vehicle has to be very, very precise, because the spacecraft doesn't have enough propulsion, doesn't have enough propellant on board to make significant course corrections. So the rocket has to provide the majority of that. And you know that if any of that doesn't work correctly, then you're not going to Mars. The mission's over. So launch is also, it's a very dynamic environment. You're sitting on top of a million pounds of basically high explosives, and a rocket is basically a controlled explosion. So you know, you're always very nervous whenever you sit on top of a rocket, just because, you know, this thing you worked on for 10 years, you know, it comes down to about an hour to get it onto the right orbit. And if it doesn't, then, you know, that's it. You can't fix it. You can't change it, because it's gone. It's very exciting though. I mean, I had goosebumps when I saw it lift off. It's awesome. It's awesome to see. This will be my this is my third space mission. The first one that I've helped develop that's launched. My other two were already in space by the time I got there. But it's always very exciting to see something you've worked on get off the pad and then get on its way to wherever it's going.
Yeah, we were also chatting. I think, you know, watching these launches live, being involved with the Cosmosphere, I have to say it is pretty exciting. So we have a room full of campers here, Michael. I don't know if you've seen that feed.
No, I haven't.
But what would you say to these kiddos here who might want to follow your path and go on to work in the industry in some fashion or another? What kind of advice would you give these kiddos?
NASA, you know, NASA works on the most challenging, difficult missions in the world, because we try to answer fundamental questions about the nature of the universe. We try to answer it. Perseverance, very definition of its mission is to try and detect ancient life on Mars. How do you do that? No one really knew 10 years ago how to do that. We're actually still trying to figure out how to do it. We have Mars sample return under development. It's not under contract yet, but it's in a study phase. And the idea is that gives us another 10 to 15 years to figure out, once we get those samples, how to actually detect if there's any life in there. That's because we don't know how to do it yet. No different than some of the other missions that JPL is working on that's going out to some of those icy moons, Jupiter and Saturn. You know, the same thing. You're trying to detect life without having a really sophisticated laboratory and a scientist sitting there to actually look at the samples. You have to use the instruments to figure that out. And, you know, it's very difficult because we don't actually know how to really do that yet. So we build missions that either are challenging to the point that industry could not support them, or support some kind of directive from the president, or try to answer some fundamental questions. So the stuff that I work on now is the lunar mission. So the lunar gateway, which is going to be the space station out in cislunar space around the moon, and the lander. You know, those are high priority directives from the president to, you know, to get astronauts back to the moon, to move us out of low Earth orbit back into sort of deep space. So those are the missions I'm working on. And, you know, we haven't gone to the moon in 50 years. You know, no one who's working a human landing system or a gateway right now was alive when Apollo was being developed. You know, those engineers are retired. Some of them have passed away. You know, that knowledge is just gone. We have to basically relearn how to fly to the moon. We have a little more experience with some robots, but, you know, we have to learn how to do this all over again. And you know, it's so exciting from an engineer's perspective to be able to work on a lunar mission. I never thought in my life I'd get to work on a lunar mission. And, you know, they're talking about the next 15 years, you know, starting to send astronauts to Mars. So, you know, the idea of having to build a truly interplanetary spacecraft to support humans all the way to Mars. You want to come work for NASA? Be curious. Want to solve really hard problems, because that's basically what we do. We solve really tough problems that no one else has done before, and That's what makes it fun. If it's not challenging, if it's not a super difficult problem, it's honestly it's not very fun. Like the more challenging the problems for us, the more exciting it is to work with.
Great. Thank you so much for that. You kind of touched on this, but going and sending people to Mars would be the next step. Is that correct?
After Artemis, so after the Gateway mission is complete, that would be the next step. So you kind of think of it like the Mars program building up to trying to answer that question. We now have to build up the technologies and have to learn how to be more self-sustaining in another environment. So not just low Earth orbit. In low Earth orbit, you can get something to the space station within a couple hours. And if you have a problem, you can just you can get in the capsule, you can leave the space station and be back on the ground within a few hours. When you're at the moon, it's a little different. You're 2 to 3 days away. You have to learn how to be more self-sustaining. So this is sort of building up NASA's confidence and testing out the capabilities to be able to support longer-term deep space missions. And Lunar Gateway is the first step. The lunar lander is just a logical buildup of those pieces to build up our confidence that we are ready to design the systems and we're ready to send crews deeper out into space. Because when you're going to Mars, it's a 6.5 month trip. I mean, you're basically on your own. You're so far away. The ground can't possibly help you. So we're trying to just logically build up that technology to get us. We can at a level of risk that we're willing to accept that we can send crews there. Spaceflight is all about risk. It's all about managing risk. There is when you send a crew to Mars, very risky because they're so far away and everything has to work perfectly or they don't come home. So we manage the risk to the point that we feel comfortable sending a crew out there, and doing Artemis in these build-up stages gets us to that point where we're confident enough with our risk posture that we can send a crew.
Right. So, and you kind of touched on this then. So we'll practice on the moon to get folks to Mars. So how would we carry enough supplies, Michael? Is that part of the Artemis missions as well, practicing that, testing that?
So the Artemis mission is, a lot of this is still sort of in development, but the idea is that the Gateway would use resupply missions, kind of like the ISS, every once in a while to send up supplies and various things out to the space station to manage it. Artemis, or the Gateway, is not meant to be crewed all the time. It's only crewed for a couple weeks at a time, and then it's mostly uncrewed. So during those uncrewed portions, we would send out supply runs and things like that to the vehicle. So it's sort of it's like the space station, but at this point, it doesn't really match Mars. Mars is very different. We would have to send a lot of those supplies out ahead of time. We'd have to do supply runs, maybe 2 years ahead of time. We'd have to send the supplies out there. We'd have to send the vehicles that can build the rocket fuel, much like the movie The Martian. We have to send supply runs with food. We have to send the supply runs for the rocket to generate the fuel. We got to do that all ahead of time because, like you said, we can't take all that. We can't take all that water. We can't take all that food. We can't take all that oxygen with us because it was just the cost to try and get that much mass into orbit would just
Okay, I think we might conclude this portion of the show here. We're going to let you leave the live feed up, Michael, so that you can come back on when we do have that final separation, that final it's all a go call. We'll come back on and we'll sign off officially then.
Okay, very good.
Thank you so much.
Yep, thank you.
They worked on Curiosity and now Perseverance, and that history, that group of folks, they're just world leaders, and it's why we're successful.
So you oversee the Jet Propulsion Laboratory in California and doing incredibly complex work. Why are these robotic missions so hard? They're hard because you can't really see what's going on. You can't use your human
responses, right? You know, you're used to driving your car and you see what's happening and you know, you turn the wheel. In this case, you know, we've got to tell the rover, we've got to prepare the rover to do a lot of that stuff on its own, right? And so we've got to understand Mars, we've got to understand how the rover works, and we've got to put all that together into a machine that can function more or less without us. So we talk to it once a day, and we say, how are you doing, and go over there and do these experiments, and then it's got to do that. So, you know, we kind of give it its intention, but then it's got to do all those activities by itself, and that's a challenge. And the further away from the Earth you get, the harder it is. So you get out to Saturn, you get to Europa, you get beyond, and it becomes harder and harder.
Yeah. Real quick, one question to wrap up. You've been in touch with the folks out at JPL. On air, there was an earthquake that played out. It was a 3.9 magnitude. How is everybody doing? How's your team?
They're doing great. You know, our view is just Pasadena. It's just the Earth being excited about going to Mars. So it was a very minor earthquake. We have them a lot in California. Okay. You know, maybe it's like hurricanes here or something, but it's tropical storms here. But it was a very minor event, and everything's fine. And we are on our way to Mars.
Okay, so a little rumble here in Florida, some rumble in California. Works out great. Mike Watkins, thank you so much. We appreciate you joining us on the broadcast.
My pleasure. Thank you.
Awesome. We will have that conversation, a conversation with Zena Cardman coming up, which I'm super excited about.
That's right.
Yeah. On the other side of the Centaur burn and spacecraft separation. We'll also highlight 6 major technologies that NASA's focusing on over the next decade, including the critical energy needs for such missions. But with that, let's turn our attention to the next operational steps. Joshua, are you there?
Yeah, Moo, we're here and we're excited. We have a fuel pre-start call just coming in. We are getting ready to hear the call for this second burn of that Centaur RL-10 engine. Again, Mick, explain what this second burn is for.
So as we talked earlier, the second burn is really to get us that velocity as we head into that transfer orbit, right? Centaur in Mars 2020 will head into that solar orbit on its way with the proper velocity. We will then get ready to separate Mars 2020 on its way. And I'm hearing that settling is done and we have main engine start.
There we go. Awesome. And again, that animation there being driven by actual telemetry data coming from that rocket. So that's a phenomenal sign. And again, I think that it's tough with these images. Perspective and scale are so important. This vehicle is in Earth orbit. It's not near anything, so you can't see the acceleration of what's happening right now. But for 8 minutes, it's going to be picking up speed.
Yeah, this is the burn that gets us really moving in the direction we need to go, that fast velocity that we need to get out of our park orbit and head on our way to Mars. Of course, Centaur and Mars 2020 are still together, and as we're hearing, everything is looking nominal on this fire so far. The main engine start was good, and the firing is going well, nominal, as we see in the animation there.
Fantastic. So this is rocket science, and it's not easy. We actually want to bring in now, we have a special guest. This is Dr. Denton Gibson, excuse me. He is a rocket scientist. His official title is Senior Vehicle Systems Engineer. Denton, how are you doing?
I'm doing well. Thanks for having me.
Yeah, did you enjoy that? Obviously, you got to kind of spectate. A lot of days, you guys sitting on console, you have to kind of focus on your computer, but you got to see this one today.
Oh, yes, and it was a beautiful launch today.
Yeah, nice sunrise. Hey, tell us about your role with LSP. I was not making up things when I said you're a rocket scientist, but what exactly do you do?
So as our role in LSP, as a vehicle system engineer, we are the engineering team lead for a lot of the rockets that we launch our science missions on. And we are responsible for the oversight and insight into these launch vehicles for the NASA.
That's awesome. And I know in the past you've supported a variety of vehicles. Tell us a little bit about the vehicles that you have supported and the ones you're focused on today.
Yeah, so some of the vehicles I supported in the past is the Delta II, which was a long-time workhorse for our science missions, as well as the Pegasus and Taurus/Minotaur C. And right now I've been focused mainly on the Falcon 9 and Falcon Heavy.
Yeah, awesome. So obviously not focused on the Atlas V, but a lot of that experience and the process is the same. I want to take a moment to pause and say Denton's there at Hangar AE. That's the NASA Launch Services Program's hangar. They're very proud of that. We call it the telemetry center of the universe. That's where the data for today is flowing. But I wanted to also ask you, is the process the same for all these vehicles? When we talk about the telemetry and these sort of processes of getting from Earth to Mars, does Falcon 9 experience translate to Atlas, or are they completely separate?
So the overall process for many of these launch vehicles are the same, whereas you ship stages to the launch site and assemble the launch vehicles by stages. So in that sense, they're the same, but there's a lot of differences between the launch vehicles that may change that process a little bit. But in general, the processes are the same.
Yeah, and Joshua, I was going to say, Denton, I worked with Denton quite a bit over the years, and he talks about the different vehicles he's worked on. But Denton is one of my senior vehicle engineers in LSP, and so although he's not totally supporting Atlas V today, he does have experience with Atlas V, and as he said, things are very similar. So using his experience, we're able to train and bring on new generation of engineers, and Denton's been a huge part of that to allow us to grow our bench, if you will, to start working commercial partners.
Yeah, awesome. So Denton, tell us a little bit about kind of what's involved, what goes in behind the scenes, what's the rocket science of going from Earth to Mars, this maneuver to go into solar orbit?
Yeah. So a lot of the things that happen behind the scenes it's a lot of analysis work done by our analysis teams. I mean, it's months and months of analyses that are performed based on the orbit insertion, the performance of the launch vehicle. A lot of modeling and simulations is done to be able to get to this point to where we can transfer from Earth orbit into solar orbit.
Awesome. And obviously, you're a rocket scientist. That's for a lot of people, that's like the pinnacle. That's like, hey, I want to be a rocket scientist. So where do you go from here in your career? Because obviously, like, I'm sure there's lots of things that you'd like to go and accomplish.
So, going from here, one of the coolest things about this job of working in the launch services program is working the launch, right? I mean, who doesn't love a launch, and who doesn't love working launches?
Yeah, we love them. We love them. Excitement this morning, right, Denton? We got to see that's what it's all about.
Of course. So, one of the ideal jobs would be a launch director, because you get to work all the launches. I mean,
Very
how cool
good.
is that?
No, yeah, that's true. And I guess you get to, is it right to say you call the shots, or is it that the buck stops with you, or how would you say that?
I'd say the buck stops with the launch manager. As today we talked, right? Omar Baez is our launch manager for March 2020, and he had to poll the team and make sure everything's ready to go. So the buck does stop with him right there on today's launch. And as Denton says, I think there's a lot of people that would love that job, and Denton's definitely looking at that next step. So I guess we need to give Omar and his assistant launch manager, Tim Dunn, a heads up.
Yeah, there you go. Dr. Gibson.
Dr. Gibson is
Up
on
and
the
coming.
way. Yeah.
Awesome. Well, Dr. Gibson, before we let you go, give us a real quick snapshot. I know you have a mission coming up later this year. What are you working on?
So we're supporting the Crew 1 launch coming up. So we're helping commercial crew out with that one, as well as Sentinel-6 as far as the LSP missions. That's coming up later on this year. And so we're excited about that one.
Yeah, a ton going on. Dr. Gibson, appreciate you. Thanks. And I want to take a special moment on the commercial crew note to comment. We've got a big day coming up.
Yes.
Pending weather. There's a tropical system that might kind of get in the mix here, but we have a tropical system that could create some problems. Otherwise, we've got Bob and Doug from Demo 2. They're coming home on August 2nd.
Yes, I was going to say, Joshua, that's important for us also in LSP. Denton was my lead VSE, along with a few others that are in the group that worked that mission with the commercial crew program. And so it's really important for us to be able to support other programs within the agency to make these things happen. As we launch Mars 2020 today, which is another step for us getting humans to Mars, right, is getting humans launched off of Earth soil was a huge step for off of American soil.
Yes.
was a huge step for us.
Yeah, and so talk about that really briefly with LSP. Obviously, Denton there, appreciate him and his contribution, and you working towards commercial crew, but also supporting Artemis, which is also part of that path of getting humans to Mars someday. Artemis is about learning to live on the moon to sustain a presence there with the eyes on Mars. So how is LSP supporting even Artemis?
Yeah, one of the things there is the Gateway program, right? Deep Space Logistics that is working a lot of that. And so LSP is in the works of supporting Gateway and helping them work with the commercial partners that are providing the rockets for those kind of missions that are out there and future things. One of the cool things about working with the Launch Services Program is that we work with all of our commercial partners, SpaceX, United Launch Alliance, Northrop Grumman Space Systems, and of course some up and comings. You may have heard some, right?
It is
like
a growing
Blue Origin.
field. Yeah.
It's definitely a growing field in the aerospace industry, and LSP takes pride in working with those commercial partners to figure figure out what we can do for NASA and the country.
Awesome. Yeah, it is an exciting time for spaceflight. The commercial spaceflight industry is booming. There's always new things happening. If you keep an eye on the news,
okay, so
you
there's a
will see
little
new
bit
things.
more
We're
left in the
getting word out
burn,
that
but
the engine
just
cutoff
watching the
here should be
data,
happening
looks
momentarily.
like
Once we see that
rocket
happen,
is now
we'll have roughly, I believe it's 5 minutes
interplanetary
until we actually
trajectory. So the
the
next
spacecraft
couple of
separation
minutes
occur.
is
So
now
we're going
to
to stay
give it
with you
that
through that,
extra
but
velocity
want to kind of just preview that for you. That hopefully on screen here, you should be seeing that engine cut off, and that's completely expected. That's a nominal operation, as you say, Nick.
Operation. We'll hear from Jesse Gonzalez, who's looking at the launch vehicle telemetry and watching the animation there. So let's listen in for Jesse here.
And there's the call, and there's the animation, again, modified based on data. So let's talk about communication for a minute, Nick, because it is not an automatic thing to just shoot information at Earth and have that be usable. So how do we go about communicating not only through launch, but on the way to Mars, and then once we're at Mars?
Yeah, so the important thing this morning is when we lifted off from Complex 41 here at Cape Canaveral Air Force Station, we had ground stations that were looking at the launch vehicle and tracked it all the way to provide data. Once we got onto orbit after stage separation, you heard a call out for TDRS, the telemetry network that NASA owns.
Information here. Are we about 5 minutes from that final separation?
Hopefully for the landing with Doug and them.
Yes.
So getting off the ground today was great because we could deconflict some of that TDRS usage.
Looks like
but TDRS is very important for us.
Looks like about 3 minutes
to get the telemetry from the launch vehicle back down to Earth here. And then, of course, when Mars 2020 separates and it gets on its way to Mars, then the JPL team will take advantage of NASA's Deep Space Network, which has been around for a long time, to be able to transmit commands and data back and forth to the Mars 2020. So it takes a lot of folks to work those, and the TDRS and Deep Space Network
at that final state where
missions, but human space.
Correct?
Yeah, I think the coordination of that is something that people don't get a chance to understand much.
So
because as you said, we're using TDRS for crew return. We use TDRS for space station.
From separation,
TDRS is not an unlimited resource. We have a good number
there's
of
going to be a little bit of time while
they're
passing through Eclipse.
It is a coordinated effort across the globe because we even have ground stations in Australia. I think where all of our ground stations.
We have ground stations everywhere, not only here in America on the West Coast and East Coast, but then you get into South Africa area, Australia. You said we have several ground stations that catch up different things for missions, but of course in orbit, TDRS and the Deep Space Network are very important. And as you said, there's not an unlimited amount of resources there in the TDRS network. So we have to coordinate those things within the NASA agency and with our commercial partners when they're used for our launches. And again, that's another part of what NASA does as an agency.
Yeah, so just on that note, kind of thinking about around the world, currently this spacecraft is roughly over the South Indian Ocean. So that's just thinking about how fast we're moving, just the amazing world of spaceflight. It's just hard to put into words sometimes of like, we're literally flying around the Earth and we're already halfway around it. And so I want to talk actually about planetary protection some more. I know we heard about that a little bit from Moo, about how they're working to protect Mars from contamination, so to speak, just putting things there we don't want. And we have to consider that, or ULA has to consider that when they're flying to Mars and delivering the spacecraft.
Yeah, it's a combined team. ULA, JPL, LSP had to look at that for when we get ready for spacecraft separation here in about a minute, right? One of the things we talked earlier is that Centaur and Mars 2020 are on the same path towards Mars right now. So once we separate, Centaur will do a CCAM maneuver, or what we call a contamination and control avoidance maneuver, and then blow down what's left of propellants in its tank. And by doing that, we have now put Centaur on a different track so that it will not intercept Mars or interfere with Mars 2020 at all for approximately the next 50 years.
Yeah.
And that took a lot of work by the JPL team and the launch team to make sure that would happen. So again, another planetary protection maneuver that had to be done.
Yeah, and I understand from the telemetry experts in LSP that this rocket actually, after the second burn, is not actually aimed straight at Mars for that reason. It's actually aimed slightly off of Mars. And so Perseverance, Mars 2020, will redirect itself just slightly. We're not talking about over 7 months. A little bit of difference here makes a lot of difference later.
Absolutely. And Josh, we heard Jesse telling us that Centaur is spinning up. This is the maneuver right prior to spacecraft separation, where we get into a slight roll to give Mars 2020 some
stable Centaur tank pressures,
stability.
Very good performance from the RCS system. and stable indications from the avionics systems as well.
So RCS there, the reaction control system, that's those small, the series of those small engines that you see firing around the spacecraft. Those are used for that in-flight operations that they need. The rolling activities, as Mick's saying, is basically providing stability to the flight of Mars 2020 as we go forward. Tell us about actually.
And we have successful separation of Mars 2020 with the Perseverance rover.
There we go.
Awesome. We got some nice applause there. That is a big moment. We are hoping to get some live video back from that because of the time delays with communicating with things in space. We don't have it at this instant.
Okay,
We're
so
hoping
that
we get to
is
see that here in a few minutes.
the last
and we'll bring that
major
to you if
event
we
of
do.
the
But tell us
launch
about
phase.
the separation maneuver, because the apparatus, the actual. It's really simple.
Acquisition of signal in
We'll
about
talk about it in a minute, but
26
as you see on your
minutes.
screen right now, you see
Canberra,
the
so
mission director, Senator
spacecraft
Ramor
is
Baez,
currently
and the team are. And Josh, you and I
eclipsed,
joked about this a little bit earlier, but
Gotta
with
get
the
out from
pandemic and
eclipse
everything going on, the
get,
teams have done
get
a
some
great
sun,
job.
solar rays,
Normally,
start
spacecraft
generating some
separation.
power.
With the Perseverance
Honestly,
rover, the
turn on
Centaur will
its
now perform its standard propellant blowdown
telecom
sequence
system.
to inert
It's
the
gonna
vehicle
turn
and complete
towards,
today's flight
Canberra, and it's gonna
after completing
hail home and say, hey,
its CCAM avoidance maneuver.
and we'll start downlinking
This
all
will
the
conclude today's commentary of the Mars 2020 mission. This is Atlas Flight Commentary signing off.
So that's the end of ULA's job for today.
Jesse Gonzalez did a great
Fabulous.
job.
So we can all take that collective sigh of relief now.
We would see a lot of clapping.
Perseverance is on its way.
Yeah, the launch part
but
is,
with the
it's done.
pandemic
So the
and
most
everything,
of the-
people
or
are
Harry's-
staying
Harry's
their
part.
distance, taking the guidelines
Finished.
seriously,
So
wearing masks with this.
next
So we
big
saw a lot of
thing
air
is
high
air
fives.
fives,
Hear from
yes,
the vehicle.
absolutely.
That does not take away from what the team
Yes,
is,
we got through,
how
we got through the
excited
work.
they are. They have done a lot of work to get to this point, and that seeing
Fabulous.
space.
Thank you again, Michael, so much for joining us today. We appreciate all that you do to support us here at the Cosmosphere, and we look forward to connecting again soon.
Yep, thank you.
We're
Bye-bye.
most of the way.
Bye-bye.
As you heard.